From page 107, number 33, we have this differential equation y double prime minus 2y prime plus y is equal to x cubed e to the x. So the first thing that we have to do is to look for the roots. So in looking for the roots, we assume that y is equal to e to the lambda x. So y prime for this is lambda e lambda to the lambda x, and y double prime is lambda squared e to the lambda x. So we substitute this to the main equation. We have lambda squared e to the lambda x minus 2 lambda e to the lambda x plus e to the lambda x equals 0. Or we can also have lambda is equal to m. So we have this equation. So looking for the roots, we have m squared minus 2m plus 1 is equal to 0, which is just equal to m minus 1 squared is equal to 0. So we can use the quadratic formula, the quadratic equation to solve this. So we have m is equal to 1. Thus, it is a repeated root. So from this repeated root, we arrive from this yc is equal to c1 e to the x plus c2 x e to the x. So solving for the particular solution, we have this y particular is just equal to x squared a1 e to the x plus a2 e to the x x plus a3 e to the x x squared plus a4 e to the x x cubed. We have x squared so that we can account for e to the x x in the complementary solution. So having this y particular, we differentiate it, so we have y particular prime a1 x squared e to the x plus a1 2x e to the x plus a2 x squared e to the x plus a2 3x squared e to the x plus a4 e to the x x4 plus 4x a3 e to the x plus a4 e to the x x to the fifth plus a4 5x fourth e to the x. So our double prime for yp is just equal to a1 2x e to the x plus a1 x2 e to the x plus a1 2x x e to the x plus 2a e to the x plus a2 e to the x x cubed plus 3a2 e to the x x squared plus 3x squared a2 e to the x plus 6a2 x e to the x plus a3 e to the x x4 plus 4a3 x cubed e to the x plus a3 x e to the x plus a3 e to the x plus a4 x fifth e to the x plus a4 5a4 x to the fourth e to the x plus 5a4 x fourth e to the x plus 20 a4 x cubed e to the x. So we substitute this to the main solution. We have this. So that is that. And we simplify this and we equate it. So we have a1 is equal to 0, a2 is equal to 0, a3 is equal to 0, and a4 is equal to 1 over 20. So we substitute this to the y particular. We only have e to the x, x fifth, all over 20 left. So we all know that y is just equal to yc plus yp. So we have this. The complete solution is y is equal to c1 e to the x plus C2x e to the x, this is from y complementary, plus e to the x fifth all over 20. And that is the complete solution.